Welcome to this video. I am HasPhysics and today we are going to be going over Young's modulus. First of all, what is Young's modulus? Young's modulus is the measure of elasticity and stiffness. It is equal to the ratio of the stress acting on the material with the strain produced due to the stress, where the formula is E equals sigma over epsilon, where E equals Young's modulus, sigma equals stress, and epsilon equals strain. So now we go into the example exam style question, where it states, a copper wire and a steel wire of identical lengths are soldered together. The compound wire is stretched by a force F and the total length increases by 0.01 meters. Using this information over here, show that the extension of the copper wire is about twice the extension of the steel wire. So first we need to write the Young modulus formula, where it is E equals sigma over epsilon. And so we can rewrite sigma as it is stress as F over A, and we can rewrite strain, which is epsilon, as extension over length. And so we can substitute these into this equation, which is E equals F over A, all of that divided by changing X over X. And so to neaten things up, we take the X to the numerator and the A to the denominator. So our formula will be Fx over A changing X. So now we want to make Fx a subject. So we multiply both sides by the A changing X. So when we do that, we get A changing X equals to Fx. So now we want to write this equation in terms of the copper wire and the steel wire. So we write Fx equals to the EC, as this one will be for the copper wire. So AC changing XC, and we do the same for the other wire, steel wire. So Fx equals ES AS changing XS. So now we can see that from the question that they are both the wires are identical lengths and the same force is applied to both of them, which means that this and this are the same. So we can make these two equate to each other. So it will be ECAC changing XC equals to ESAS changing XS. So now we want to make the change in X's and the EAs on the other side, on other sides. So we divide both sides by the ECAC, so we get change in XC equals to ESAS divided by ECAC, and this is multiplied by changing XS. So now we just divide both sides by the change in XS. So we're left with this equation. So changing XC over changing XS equals to ESAS over ECAC. So now we've separated the change in X's on one side and we put the EAs on the other side. So now we can substitute these values into this part of the equation. So when we do that, we get 1.8 times 10 to the power of 11 multiplied by 1.3 times 10 to the power of minus 6, and this is all over 0.8 times 10 to the power of minus 6. This is the cross-sectional area of the copper wire. I accidentally pointed the wrong way around. And this is 1.3 times 10 to the power of 11. Ignore me putting these two in the wrong order. Should still make the same answer. So when we do that, we get 1.8 times 10 to the power of 11 multiplied by 1.3 times 10 to the power of minus 6 divided by 0.8 times 10 to the power of 6. And so we get the change in XC over change in XS to be 2.25. So now we make the change in xc the subject. So we can see that the change in xc equals to the change in xs multiplied by 2.25 as we times both sides by changing xs. So we can see that the extension of the copper wire is 2.25 times the extension of the steel wire. So we can write therefore the extension of the copper wire is about twice the extension of the steel wire. And there you have it, that's part I done. So now we're going to part II, where it states, hence calculate the extension of the copper wire. So, we know that the ratio of the copper wire to the steel wire is 2.25 to 1. And we know that the total length increase, so the total extension of the copper wire and steel wire, is 0.01, as it states it here. So, because we don't know the extension of the steel wire, we can just label it as x. So that means that we can rewrite this as 2.25 x colon x, because we don't know the extension of the steel wire yet. So we can see that 2.25 x plus x equals 0.01, because 0.01 is the extension for the whole wire, which include the copper and the steel wire. So we want to factorize this, so it is 1 plus 2.25 x equals 0.01, and so you divide both sides by what's in the brackets. So when we do that, we get 3.08 times 10 to the power of minus 3. So now we found the extension of the steel wire. So now we need to find the extension of the copper wire, and we can just multiply this by 2.25. So when you do 3.08 times 10 to the power of minus 3 multiplied by 2.25, we get 6.92 times 10 to the power of minus 3 meters. And there you have it. So thank you for watching this video. I hope you have learned something from this video, and it would be really appreciated if you could share this video and subscribe. Have a fantastic day.